In this example, we have a complex number getting divided by a second complex number. So just like in our previous examples, we got to look at the denominator and multiply numerator and denominator by the conjugate. So here, since we have the form a minus bi, we're going to multiply by a plus bi. So the conjugate of 5 minus 2i is going to be 5 plus 2i. We're going to multiply the numerator by the same quantity. Now for the numerator, we have two complex numbers, so let's go ahead and multiply those together with the box method. So we're going to get 1 and 3i, multiply it with 5 and 2i. And doing the multiplications, 1 times 5 is 5, 1 times 2i is 2i, 3i times 5 is 15i, and then 3i times 2i is 6i squared. We're going to look at the diagonal and combine like terms. 15i plus 2i is 17i. So the numerator can be expressed as 5 plus 17i plus 6i squared. Again, 5, 17i, and 6i squared. Now the I squared, we can exchange it for a negative 1. So we get 6 times negative 1, which is just going to be negative 6. Now the 5 and the negative 6 are like terms. They're the real part, so we got to combine them together, and they give us negative 1. So we get negative 1 plus 17i, since we still have that 17i there. So this is the numerator. And now we're going to simplify the denominator. But the denominator is just a multiplication of complex conjugates. So we're going to get 5 squared plus negative 2 squared. And 5 squared, that's going to give us 25. And negative 2 squared, that's going to give us a positive 4. And 25 plus 4 is going to give us 29. This would be our solution. Let's check out another similar problem. Here the denominator is of the form a plus bi, so we're going to have to multiply by the conjugate a minus bi. And in this case, the conjugate of 3 plus 4i is 3 minus 4i. We're going to multiply the numerator by the same quantity. And let's begin with combining the two complex numbers on the numerator. So we get the multiplication of 1 and 2i with 3 and negative 4i. So multiplying through, 1 times 3 is 3. 1 times negative 4i is negative 4i, 2i times 3 is 6i, and 2i times negative 4i is going to give us a negative 8i squared. Looking at the diagonal, 6i minus 4i is going to give me 2i. So we can express this as 3 plus 2i minus 8i squared. And I squared, we can exchange it for a negative 1. So then we get negative 8 times negative 1 is positive 8. Combining the real parts, 3 and 8, that's going to give us an 11 plus 2i. This is the numerator. Now we're going to simplify the denominator, which is a multiplication of complex conjugates. So we can look at the 3 and we can look at the 4, and then just sum the squares of those two numbers. So we're going to get 3 squared plus 4 squared. So we get that this is going to simplify to 11 plus 2i all over 9, since 3 squared is 9, and then 4 squared is 16. So our final answer is going to be 11 plus 2i all over 25.